Okay, it's a tough question, this, right? And you can certainly draw a picture to help you. That might be an idea, right? You can get a sense of what's going on. So we've got coordinate axes. We've got 2 coordinate points. A is -1, 2. There's A. And -1, 2. And B is 5, -2. So something like this. 5, -2. There's B. And find the equation of the line that is perpendicular to AB and passes through the midpoint of AB. All right, well, this I think is making more sense now. If I kind of connect this, it's not to scale, but the idea is that we want to find the midpoint of AB, and then we want to find the, oh, that's interesting, let's do that again. We want to find the midpoint of AB, let's call that M. We find the equation of the line perpendicular. So basically, we want to find the equation of the green line. All right. So I think it might help to draw a little picture, even if it's not to scale. All right. So you can see that if we think about this line, the green line is y equals mx plus c. So we certainly want to find the gradient of the green. Now let's think this through. The gradient of the green is connected. So the gradient of the green is connected to the gradient of the black, right? So AB gradient perpendicular is this guy here. Remember, if the gradient of one line is 3/2, the perpendicular is flip it and opposite sign, right? If the gradient of one line, flip it and change the sign, right? Because that 2 is 2/1. So we can keep doing that, right? If the gradient of the first line is this, then flip it and change the sign. If the gradient of the first line is this, flip it and change the sign. So perpendicular gradients have that property. The gradients multiplied together is equal to -1, or a nicer way to say, if one gradient is A over B, the other is flip it and change the sign. All right, so that's key. So you need a few formulae for this one. So certainly, let's consider, let me just get the right colour. Okay, let's go back here. Let's deal with the black line AB, all right? So the gradient of AB, y2 minus y1 divided by x2, subtract x1. So be careful that when you subtract, you know what you're doing, right? So this is -4 divided by 5 plus 1, 6, which is -2/3, okay? Now that's good, -2/3, it fits with the diagram which we've got, it's downward sloping, all right? And now we need to find that midpoint. So let's go for the midpoint. Now this is where we add the x and y coordinates and divide by 2, we've got to find the average, all right? So for this guy we have -1 plus 5. So let's go ahead and do that. So that's -1 plus 5, the average. And now the y coordinates, the average, 2 high, -2 high. So we need to find the average there. 2 high plus -2 high, find the average. All right. So this first one is 2, and of course the second one is 0. Yeah. So actually the way I've drawn that picture isn't quite right. That M is actually on the x-axis, right? So maybe you just big fat M. There you go. So I think we've probably got all we need. So now let's switch out to the green line. So the green line now, let's get the green pen. So green line. Well, look, the gradient of the green line, remember what we said? It's the flip of this. So it's 3/2, and it's positive. And we know the equation is y equals mx plus c. So we know the equation of the green is y equals 3/2 x plus c. We've just got to find the plus c, right? Got to find this plus c. It looks like it's maybe a negative answer. And to find the plus c, we just need to substitute an x, y pair of numbers that we know is on the green line, and we know that this m is on the green line. So we've got to substitute x is 2 into here, and y is 0 into here. So let's go ahead and do that and see what we get. Okay, so let me just make that a little bit bigger. So y equals 0. 3 over 2, x is 2 plus c. And I've got 0 equals 3 plus c. I've got c equals -3. So I've nearly got my answer now. I've got y equals 3 over 2x minus 3. And that's so close to the final answer. Now that is the correct equation of the straight line that we're trying to find, the green line. But when we look at the question, look, so we've got y equals 3 over 2x minus 3, but it wants ax plus by equals d. So we need the x's and y's on the same side, but look, we need a, b, d as integers. So the key thing here is that we are going to have a little look at this equation. We cannot have any fractions. How do you get rid of fractions in an equation? Times both sides by 2. 2y here. 3x over 2 times 2, the 2 cancels. 3 times 2 is 6, and we've got it. We've got 2y minus 3x equals to -6. And that's the final answer that we want to get to. And that final step, getting it into the correct form, where a, b, and d are integers, that's a little bit naughty.